Yes, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at the interesting part of the concept of projectile motion. And this is going to be assisting us trying to represent this aspect of the horizontal displacement that is going to be traveled by this specific object before it returns to the ground. And in our last discussion, I had basically given an illustration of this specific kind of a motion which we said is going to be exhibiting both displacement in the x and y direction. And we had given a particular curve which we had named perhaps particularly a trajectory, which this specific, of course, projectile is going to take. Now, in this case, we had said that we can describe the velocity component along the x and y axis given in that specific representation. And of course, we are going to have the velocity given as v naught, which is going to be a resultant of these two specific components. Now, if this particular trajectory is going to be, or projectile is going to be launched at an angle, we're going to see that it's going to travel to a specific height, which is going to be given in this particular case as perhaps we can give it in terms of a h. So it's going to travel with, of course, reducing inertia until it reaches its maximum point at a height h, whereby the velocity component along the y-axis is going to be equivalent to 0. And therefore, we are going to see that it's only going to possess the velocity component along the x-axis, which is going to be given as such. Now, upon its return to the ground, we can as well describe its velocity component in terms of the, of course, the components of x and y. And of course, we're going to see that at the end, we're going to have this object coming to the ground at this specific point that we're going to give in terms of a stretch between the original point of a launch to that one given in terms of a stretch over x. And therefore, that's going to be forming one of our point of interest, which we are going to refer to as a range. Now, if we look at this specific illustration, we're going to, of course, consider some of the kinematic equation which we had looked at from our previous discussion in trying to describe this specific aspect of horizontal displacement given in terms of a range, which this projectile is going to travel, of course, before it returns to this particular part of the ground. And this is going to be achieved from the equation of the form v y naught t minus a half gt, the square of that one. And this equation is going to be assisting us try to find the time element which we are going to be obtaining, which is going to assist us, of course, to evaluate the concept of displacement along the x-axis. Now, in this case, we are going to consider for this specific curve points whereby we're going to have the value of y equivalent to 0. And one of these points is at when this specific, of course, projectile is going to be launched, which is going to be t is equivalent to 0. And another point is whereby we're going to have this one. Perhaps we're going to have this one at the point of origin, this, or at the point of a launch, this time is going to be given as 0. But at the time which it's going to land at the ground, we are going to give it as no. So let's have this one as t1, and we're going to use it as such. So in this case, we're going to see that for us to find this time element, we are going to do an evaluation of this one, whereby this specific equation of v is equivalent to v y naught t minus a half gt, the square of that one is equivalent to 0. Therefore, we're going to do this specific, of course, evaluation, whereby we're going to have this one g, the square of this. So we're going to make t the subject of this specific formula. This implies that we're going to have this one equivalent to a half g t squared. So in this case, if we make t the subject of this formula, we're going to have t equivalent to this specific value given as such. And for our evaluation, we're going to see that for us to find, so this might be small. So for our evaluation, we're going to see that the displacement which we are going to be after can be given in terms of x, whereby x is equivalent to the velocity component along the x-axis times the time. Now that we have found the time element, therefore we can have this displacement given in terms of vx naught, and then we are going to have 2 vy naught all over time. But we had learned from our previous discussion that this basically is going to be a component which is a resultant that is going to have the x and the y components. And therefore, we can represent this specific components of Vx naught given in terms of this v naught, the cosine over theta. Now in this case, we're going to evaluate this one from a right angle, of course, perspective for us to find this resultant v naught, whereby we're going to have a vx naught and vy naught given as that. So for us to describe this specific aspect of the vx naught in terms of these trigonometric functions for the angle longe over 60 degrees, we're going to have a vx naught represented in terms of a v naught and then the cosine over this angle theta, and then we're going to have a vy naught represented in terms of a v naught, the sine. So we're going to have this one as the sine over theta, and therefore for us we can just do a rearrangement. So let's call this one our equation 1 for time. So we're going to have our equation 2 for representation of the displacement along the x-axis, which is going to consist of this component of the velocity along the x and the y twice the y. So this is going to be over g along the y component given as that one. So we're going to do to rewrite this displacement in terms of these two specific terms which we have derived for the velocity component along the x and y respectively. So that is going to give us what we refer to as a displacement, which is equivalent to, so the vx naught is equivalent to this one, which is a v naught, the cosine over theta, and then we're going to have into the value of a vy naught, which is a v naught, the sine over theta, and then we're going to have this one all over g. In our different discussion on the concept of trigonometric functions, we have talked about the concept of double angles and other evaluations which are going to consist of two functions of the trigonometric, of course, functions of sine, cosine, and perhaps a tan. And in this case, we're going to see that we're going to have this the cosine over theta and the sine over theta as one part of this specific function. And then we're going to have the square of v naught, which is going to be given by this specific product. So in this case, we're going to have perhaps this one is still represented as such, whereby we're going to have this as our, of course, displacement. So we're going to have this v naught and v naught forming the square of this one. And this is going to be two numerical, of course, as we can refer it as a coefficient given as such. And then we're going to have the cosine and the sine of these two specific functions combined to form that. And in this case, I've just done this one deliberately. Now that this one, whereby we're going to have the cosine of theta and the sine over theta equivalent to this specific function of this, to the sine of theta. And therefore, we can do a substitution of the above equation by doing a replacement of this particular function, whereby the displacement will be equivalent to v naught squared, the sine over 2 theta all over g, and this is going to be forming what we refer to as our range. So therefore we can illustrate our range to equivalent to v naught squared the sine over 2 theta all over g, and this is going to be forming our horizontal displacement, of course, traveled by the projectile before it's going to return to the ground. So I'd like to request our members to be kindly checking our description boxes for various links of other videos. Engage us in the comment section and also ring that notification bell for various updates on different subjects that we're going to do, or topics we're going to do in math, physics, and chemistry. So this is going to be perhaps our final bit of this specific discussion. And I'd like to invite members to request more members to join us so that we can form a large community of members discussing the various topics which I've mentioned. So that is it for now, guys. Bye, God bless you. Catch us in our next video.